Hello everyone, welcome back to another video. My name's Jared Beckwith and I'm visiting my brother Christopher here in Minnesota with my mom. We're out here just visiting, and there's my brother's new cat Priscilla. She keeps him company here in Minnesota, and we've been working on a project. If you've seen my previous videos that I showed how to use independent component analysis for eye blink artifact removal, I went in and I showed that an EEG is made up of different independent components. Like, for example, it's made up of brain signal, it's made up of muscle artifact, it's made up of EKG artifact sometimes, it's made up of 60 hertz interference sometimes. So it's made up of a bunch of different things, and these are each individual independent components. And I was able to look at each of those and find out which one is the eye blink. And I was able to subtract the eye blink and remove the eye blink artifact from the EEG. Independent component number 5 is our eye blink, and that's what should be subtracted out of the data. So let's get rid of this. Now, that's good and all, but if you want to do it automatically, you can't have a human going through every single EEG every single time and manually subtracting the eye blink independent components. You're going to want to do it automatically. And the way to do that automatically is through an artificial neural network. So the computer automatically recognizes which independent components is the eye blink, and it subtracts it automatically. So my brother Christopher, he's going through artificial intelligence class, and he's been working on a project. This is just the first week, first version, but we've been doing really good, and we have some code here, and we have an artificial neural network that correctly labels eye blink independent components 83.8% of the time. That's just our first figure. Like, we literally just put this up together in a short period of time. So that's our baseline number, and we're going to improve from there. We have many different ideas on how to do that, and we're going to be able to automatically subtract eye blink artifacts from the EEG, which will be good for our brain trending analysis, so we can look at the trends of the brain data, so we can subtract artifacts from the EEG and just look at the trends of the brain data. And we also have a PhD student. She's looking into muscle artifact removal using a different technique called canonical correlation analysis. So we're going to have kind of like a hybrid artifact remover, and it's going to be great. So muscle artifact removal is good for when you have a patient who has a seizure. Seizures produce a lot of muscle artifact on the EEG, and you're going to want to localize, find out exactly in the brain where the seizure is coming from, because some focal seizures, like, they will start in one very specific area of the brain, and the doctors want to know where that is, and it can spread to other parts of the brain. So you want to know where the seizure starts, and by removing the muscle artifact without affecting the brain signal like a high frequency filter, that's a very valuable tool. So that's what we're building here, guys. So this is just the beginning. We're here at Christopher's place for Thanksgiving, hanging out, making progress on our new artifact removal software. Our company, Ion EEG, artifact removal isn't out. We're waiting on perfecting it. And as we get better, then we'll get FDA approval, and then we'll let you guys test it out at your hospital. So not available yet, but stay tuned. You guys can see the journey from nothing, literally, to the first version, which I just showed you right here, which is 83.8% accurate right there at determining which independent components are the eye blink, so we can automatically subtract them out of the EEG. And we also did one on muscle activity, but independent component analysis, this technique for muscle artifact, it doesn't completely separate it into, oh, this is just muscle. It'll actually have brain activity as well, which is why independent component analysis, while it's very obvious which ones are eye blinks, the muscles combined with some brain data as well. So this isn't the best way to remove muscle activity, because you'll be deleting some of the brain activity as well, and you don't want to delete the brain activity. That's what the high frequency filters do, and you know, there's a better way to do that called canonical correlation analysis, which our PhD student intern is working on, and we're also going to be showing that prototype as well. So many different things in the works. Thank you all for watching. Make sure you hit the like button. Hope you all have a happy Thanksgiving, and I'll see you guys on the next video. Priscilla says happy Thanksgiving.